In today's video, I'm going to compare just normal factorizing and completing the square, and then kind of show you that we're going to get to the same answer. Now, you might think, but what is the answer? I don't really have an answer, but sometimes these trinomials are written in form of an equation. So we have this is, for example, equal to 0. Now, why equal to 0? Okay, let me quickly go into it. So we're going to take a bit of a detour, but let me explain. So you must be familiar or should be familiar with straight lines. So if I gave you this y is equal to 2x plus 3, this is the formula for a straight line. And it's a very straightforward straight line. It goes like this. Very, very simple. If I have a Cartesian plane, it would be somewhere around there. Okay, with this being the 3. If you don't know how I just knew how to do this, then you should watch the series on linear functions. And yeah, so basically this part is if I ever wanted to know the x-axis or the x-intercept, then I would make y 0. Make y equal to 0. And then I would be like, oh, okay, 0 is 2x plus 3. And then I take that over. So 2x would be negative 3. And x would be negative 3 over 2, which is negative 1.5. And that would kind of be negative 1.5 then. Okay, so whenever I make the y-intercept or the y value the input, well, which is actually the output, but if I make it 0, then I'm going to get the x-intercepts. Just like when I make x 0, I'm going to get the y-intercept. Quickly do that here. 2 times 0 would be, well, let's say plus 3. And then that would be y is equal to 3. And that's what I said here in the beginning as it crosses the y-intercept there. Now, these are linear functions. And after this series, or we'll do a series on graphs, and we're going to do quadratic functions. And quadratic functions look something like this. So y is equal to this, or another way of writing it would be f of x. And I know that looks very, very strange. It's the same thing. So basically this is just the function of x. And wherever there's an x, if I had to put in a 2, we'll do that later. So it's not too important for you to understand this right now. But all I'm trying to say is this is something that we can draw as well. That's actually the whole detour I took now, is to explain that this trinomial is a quadratic function that can be drawn. And whenever we have this, sometimes we want to find the roots. And you don't have to worry too much about the roots right now. But what we will do is, in order to find the x-intercepts, we'll just make y 0. So we'll write it like y is equal to x squared plus 6x plus 5. And then we'll try and figure out, we want to find out what the value of x is. So this is something that we want to solve. Just like we had 5 plus x is 3, and you're like, okay, well, x must be 2. In this case, we have x squared plus 6x is equal to 5, and we'll have to do a lot of stuff to solve it. And the best way to solve a quadratic function is to put everything on the one side, well, 0 on the one side, and factorize the other bit. Okay. So don't worry too much about it. All I'm adding here is an equal to 0. Okay, that's basically all. Let's just do it the same on both sides. It doesn't really matter. Okay. So this, you should know, we can follow a small trick or an easy trick where we say, what two numbers, if I multiply them, I get 5. Well, there are a couple, but whole numbers, there are only basically 2. So I can put the x's in here, and then I know the 1 and the 5 is going to work there, and I have to get a plus, so both are plus. Okay, so this is pretty simple. To get from there to there, there are videos to show you how to do that. You should be familiar with that right now. And yeah, that's pretty straightforward. Now, I'm going to have to explain something else before I can continue here. So what I see here is I have two things that I multiply with each other, and they give me 0. So let me just do a little bit of a quick thing in here. So let's say I have x times 5, and that is 0. what should x be? There's only one option. X can only be 0. So the only thing here is x is 0. That's my solution. But if I had x times y gives me 0, then suddenly I have an unlimited amount of answers. Because x can be any number. So let's say x was 100. In order to get 0, y should be 0. Or x can be any number, but y has to be 0. I can't take, even if I were to take the smallest numbers I could, like 0.000000001 times 0.0000001, that would not give me 0. So I can't make the smallest numbers. The only possible solution for something like this is the y has to be 0. Or if the y is 100, then x has to be 0. But one of these two has to be 0. And that's what we call the null rule. Is if I multiply two things and the answer is 0, then, either the one or the other one is 0. So I have two solutions here, which is kind of weird, I know, but x can be 0 or y can be 0. But that's a must. There's no other explanation around this. Either the one is 0 or the other one. Now, just like this x and this y is multiplied, now I have a whole bracket here and another whole bracket. And one of these has to be 0 to have an answer of 0. So usually how we solve this, we would go about and we say, okay, so either this whole bracket, which is x plus 1, has to be 0, or whatever this bracket is x plus 5 is equal to 0. And now I can just do a normal kind of rearranging of formula. So x would have to be -1, or x has to be -5. Let's just check. If I were to put -1 in x's place there, then -1 plus 1 would give me 0. And it doesn't matter what this is, it will give me 0. I'm just going to test it, but you would kind of agree. So let's say I put in -1 there. -1 plus 1, and then that would be -1 plus 5. So -1 plus 1, that would be 0, times -1 plus 5 would be plus 4, and 0 times 4 would be 0. And the same way, if I put in -5 there, that would be 0. So it's a bit of a new concept, I know, but just understand that because I'm multiplying two things and my answer is 0, I can have, two answers. And I know it's a bit weird that we have two answers, but usually when we look at quadratics or numbers that are like square numbers, let's say quadratic equations, then we'd have two answers. So for example, let's say I had x squared is equal to 9. What is x? Now your first thought would be x is 3, and you would be right, but x can also be -3, because 3 times 3 is 9, but -3 times -3 would also be 9. So whenever you have a quadratic equation, meaning there's a square in an equation, then we would have more than one answer. So in this case, I have a 3 and -3. In this case, I had like a -5 and a 1. Okay, so that was a lot of information, I know. But basically all we did now is we factorized as we used to, and then I just told you this new null rule thing about, okay, well, either this is 0 or that is 0. Now I'm going to do completing the square on this side, and I'm going to see if we can actually get to the same numbers, because effectively completing the square and factorizing should actually give me the same answers. The only reason I usually prop to completing the square is because on this side, I might not be able to get nice whole pretty numbers like a 1 and a 5. But I can still follow the same process. So I would do x squared plus 6x. And in the previous video you saw me, I kind of put the plus 5 very far away. But now I'm just actually subtracting 5 on both sides. And I have -5 on this side. Okay. What was our next trick? We had to write x, I don't have to do this. I'm gonna add the number in a different color here. So I asked myself, 6 divided by 2 is 3 times itself would be 9, so I add 9 on both sides. In the previous, when it wasn't an equation, we did plus 9 minus 9. It's actually the same thing, because if I wrote plus 9 minus 9, if I took the minus to the other side, it would just be plus 9. So it doesn't really make a big difference. But it's an equation, so I just make sure I do the same thing on both sides. Now, once I'm done with this, I know this is going to be a complete square. So this is going to be x plus 3 squared. And this I can solve. I can say 9 minus 5 is 4. And now I have an equation with a kind of a complete square on this side. And lo and behold, I'm very fortunate now to have a square number on that side. But what I do now is I just take the square root on both sides. Sorry, square root. But now I have to remember, because this is a quadratic equation, and I saw that x squared equal to 9, for example, has two options. X is actually plus or minus 3. I have to remember to put a plus and a minus here. Okay, I know the plus and minus sign is also a new thing. You might be like, what on earth is going on? But just bear with me. So if I were to take the square root of this whole thing, then I just get x plus 3. And here the square root of 4, I'm just going to put the plus minus there because we talked about the two answers. Here it would be 2. So again, I have two answers. I'm going to move x to be the subject. So I'm going to do plus or minus 2, and the plus 3 is going to go on that side and becomes a minus 3, or I'm just subtracting 3 on both sides. Now, this might look weird because you're like, what is this plus 3? So it just means there are two options. So the one option is x is equal to 2 minus 3, or the other option is x is equal to minus 2 minus 3. And if I were to solve this, then x would be negative 1, or x would be negative 5. And wow, it actually worked. I didn't lie to you. So completing the square does work. And although this route would not have been necessary because this route is quicker and faster and easier, I just wanted to compare the two to show you that I'm not lying. And there was a lot of extra valuable bits in here. For example, the null rule we talked about, and that plus minus thing there in an equation, in a quadratic equation, is very, very important to understand.